Good afternoon. Welcome to the forum. Today we are very happy to have Austin Henderson to give us a talk on Trillium. Austin grew up in Toronto and is a Canadian citizen. His Bachelor of Science degree in mathematics is from Queen's University in Kingston, Ontario in 1965, followed by a master's degree in computer science from the University of Illinois in 1967, and a PhD from MIT, also in computer science, in 1975. Concurrently with school, he held software R&D positions in several places, including the Lincoln Lab and Bolt, Beranek, and Newman. And after he graduated, he joined BBN and to design and manage the implementation of the Hermes message system. And in 1978, he became a charter member of what is now the Intelligent Systems Lab, where his current research interest focused on user-system interaction and tools to support the design of user interfaces. And he's married and has 3 children, and he enjoys sports and music. So this is a brief introduction for our speaker today. And now let's welcome Austin.
You're supposed to say something about the bridge of the Starship Enterprise at this point. We've got everything working here. We're waiting for Ken. Do we have? Oh, there we go. All right. Let's back up this and do it right, seeing as I worked so hard to get that one working. Trillium is a design environment for copier interfaces, and I could go into a technical talk. Focus. Come in tighter on the slide section, Ken. Good. I could go into a technical talk about what's happening. This is terrible. I wish I could be at this forum. What I really want to talk about is not the technical aspects of Trillium, although I'll show you a short demo for those of you who haven't seen it in one form or another. But mostly what I want to talk about is the process of building a community, how it started here, continued with the cooperation with designers in various different parts of the company, and over the last year or so is really become It's owned by the design community. As I say, I'll mention technical aspects, but that's not the focus. This talk is probably indicative of the kind of thing that interests us within ISL, namely as much the interaction between people and machines as it is the machines themselves. The notion of the focus of the talk, and at the end, I'll be saying some things about the history of how the Trillium community actually grew, and then make some remarks at the end about I say it in quotes, technology transfer, because I don't even think of it as transfer. I think that's the wrong metaphor. So what I'm going to say is something about how it started. Give you some demonstrations, and talk about 4 different transfers, if you like, to the interactions with these different communities, then how they've managed to take over, and then some thoughts about what that might imply for technology transfer. In the beginning, there was it started 3.5 years ago. This is the timeline which will recur from now and again. The operability project is the basis, the place in which Trillium arose. We built a simple model, then a simple version, and then we made contact with someone whom it looked like it might be interesting to work with, and then we actually decided to make Trillium a product or a project in its own right. So let's look at that a little bit. The operability project started by an inquiry outside Park, namely from people within the service group of what was RTG at the time, the Reprographic Technology Group, saying, what happens if we put a display on a copier as the control panel? What will that do to us? In service, we think we know what to do with that, but how could that help us? How could we get somebody else, particularly the industrial designers who worry about the operability and the user interface of the machine, how could we get them involved in supporting the expense of a display as the control surface? And we thought about that and said, yeah, that's an interesting problem. Let's work on it together. And then, as we do in research, we immediately said, but of course, you're asking the wrong question. You focused it around the technology. What you really want to ask is roughly speaking, what is the technology in service of? What is this business of operating a machine? And so, what we then did with Lucy Suchman being the central person doing this work was do some analysis of people operating one of our less successful copiers, the 8200, less successful from the point of view of the user interface, and looking at what the work actually was. That's a whole story in its own right, and I'm not going to go into it at this time. What became clear as we did that is we were beginning to get ideas about what we might do to solve some of the problems that she was turning up. So we said, well, okay, we're about to go into building some new interfaces. You know, we're going to start focusing on new paradigms, which might be suggested by what we know of AI and intelligent computer-aided instruction. We're going to start building new interfaces. And then the immediate thing came up, well, okay, how are we going to do that? Well, the obvious sort of thing was to just build it in your favorite programming language. Ours was InterLISP-D. But I thought in the process of thinking about doing this, and in the process of finding out what displays on copiers within Xerox really were like, I thought it might be a neat idea to wander around and find out what had already been done within Xerox. How is, in fact, were interfaces designed if you weren't equipped with InterLISP-D? As I did that, I found that for the most part, software people got in and wrote software, usually at a fairly low level, as the machines were actually rolling out the door, or very much in the end of the process. Sometimes they had a rough sketch of how it should be given to them by the industrial designers. There was one case, the 5700, which had a display on the copier in which they had actually done simulations, again with a software person in the loop, a designer speaking to the software person, going around the loop, it taking months from the time of the specification to the time you actually saw what you like. But at least there was some trips, there were a number of trips around the design loop. Actually, of course, it was a danger because what happened was they had all these neat ideas and they were prototyping them all up, and the moment that marketing saw it, they said, sell it. Okay, so it's a very diverse and uneven interface because, in fact, the first time you get something out there, somebody's going to see it and love it. That's a warning. Make sure that when you're showing something to someone, you've got 4 other interfaces which are just as nice and all of which are different so that they have the problem of deciding which one is the interesting one to go with. That at least slows them down. Okay. That's the claim. All right, well, so I was wandering around. It seemed to me that we could do a better, we could do it more quickly, obviously interactive graphics. Why don't we build a prototyping system? I took a shot at doing so. I called it Trillium, just letting my chauvinism show. Trillium is the provincial flower of Ontario. No, it's not Valium. Well, once I had this in hand, I wanted to, I thought, well, it might be interesting to show people what we're doing again, it's within the operability project, why don't we show it? So then the question was, well, how do I show it? There's nobody out there who had the machines on which I could run it. So what I did was I took a piece of videotape. And again, let me make a pitch for the fact that videotape was a wonderful way of showing off all of this kind of stuff. Took a 5-second clip, headed off to Rochester on one of my regular visits when we were talking about operability, and showed it to the service folks. And they said, that's sort of neat. I don't think we need it, but I'll tell you who does. And they pointed me at a different part of Xerox, the industrial design operations folks. Went over there. They said, oh, I know who you should talk to. There's somebody working on the Sanda project. That was part of IDEO. It was a foam core mock-up. They're into doing these simulations. Why don't you go talk to them? I went talk to them, and what I found was a designer and a support programmer working together to build these interfaces. And I played with it for a while, and then asked what for me is a key question. How do you two talk to each other? How do you, the designer, describe the behavior that you want out of the interface? I'm saying this to Pat Wall, how do you tell that to Kathy Matisek? And both of them looked at me and broke down laughing. They said, that's been the hardest thing that we have had to fight in this thing. Yes, selling it was its own problem, but learning how to talk to each other and building up the words and the vocabulary in which to talk about behavior was something which had been very hard. Well, that led right away then to the thought that maybe what we ought to do is maybe there were some better ways, not only of, I mean, it was the same question for me, because the question in a prototype is, in what terms are you going to describe behavior? If you're describing interfaces, it's not just enough to do the graphics. You have to do the behavior too. So in what terms do you describe it? Well, I had instinctively done something in Trillium. And so I said, look, let me show you. Why don't we look to see what that would look like? So they came out here for a couple of days. And we had a session. They brought out their description of the Sanda interface. And they rolled it out on the table. It was a flowchart 10 feet long. And it's sort of, if you push the following button, then the following things will happen. And we sort of looked at that, and over time we began to work out what in fact was the underlying structure of that, the deeper structure of what was going on in there. Kathy said something very important. This is the programmer. She says, I need a bookkeeping system. I need something that will help me keep track of all the stuff I need to keep track of. All right. A month later, they came out, and we tried to rebuild it in Trillium, which pushed the heck out of Trillium, but established that the ideas were probably worth pursuing. And we established, and this is important, the ability to talk to one another. It turned out that what we were doing was the same kind of thing that they were interested in doing. And the whole story here was finding, they had a need. They had a couple of strong needs to do these designs, to do them quickly, but a way of actually describing them was important. And what was happening here is right from the very beginning, we were beginning to make contact. And the story is not so much technology transfer. I mean, it's not a matter of taking something and pushing it over there at all, the so-called throwing it over the wall, the relay race. It's much more a question of working, in this particular case at least, of working from the bottom up, where the individual skills and unique capabilities of both sides are working together to push ahead, where research is doing its thing, and the people who are using it, the designers, were doing their thing. Well, what we needed to do, when we finished that, and they sort of said, okay, let's go ahead, suddenly there was the question, wait a minute, I've been doing this thing with Trillium, I've been building it as it needs to get built. We need to change it so that they can do it in their environment. What I then did, and this is just the technical point, I moved from an implicit description of the idea of the abstractions that were inside the program to a much more explicit description. Those things, so that made the knowledge about the abstractions, the design vocabulary, if you like, available to the program for other than just, of course, creating the behavior, but also for instance, doing documentation, for, in fact, looking for having program create abstractions, help the designer create abstractions on their own right. The standard story about taking the implicit knowledge and making it explicit, providing you the way of getting something that the program can help the designer with the abstractions itself without having to go through the programmer. Well, where are we now? We're down at demonstrations. Okay. The obvious comment here is that this whole thing is done in Trillium, and so this is sort of one way of using Trillium, which we're exploring with lots of different things. But what we have then is a bridge between the organizations, a bridge between the management. A very important point that throughout this, management had been aware of the potentials of the cooperation and had been making it possible in some subtle and some explicit ways. There had been contact between Arnold Wasserman and John Brown about this whole kind of cooperation, about what the benefits might be. And John was very, very helpful in making possible some breakthroughs for me in understanding how this is done. And then there were the people. The particular breakthrough that I really remember focusing on was this notion of complementary goals. That it's often the case when you do a cooperative project that you'll hear people saying, well, now we got to decide what our goals are, what we're doing. And the we having the goals is an impediment to getting to the point where you want and this sort of thing, because of the fact that you're trying to do a complementary thing. What often happened in the Trillium case is that a problem would arise. And for the designers, that's a, oh, damn. And for me, it's an oh, boy. Because what that's producing is an interesting problem, an interesting thing about design or the problems of design, an interesting thing about the software. For them, it was a problem. We have to fix it. The goals are just very different. They would do things and spend lots of time doing things that were not of interest to me. And you'll see some of the things that they have built. I have some slides of them. Things which I would not do here. But they, in fact, had very powerful needs within their own needs to use Trillium in their ways. And I've been amazed at what has, in fact, happened. You can see these complementary things. However, there was one thing that had been focused on strongly by John and Arnold, this whole notion of taking a tool, which we're now going to be sharing, and using it as a vehicle for taking ideas and moving them around the community. Originally, we thought in terms of taking the ideas out of research and pushing them down the line and having them arrive in the community at the far end for the designers. Take what we're learning in the operability project and slide them down the slide. That is happening. As important is what's happening within the community itself, of ideas between the designers flowing around, so that we're getting, in fact, a flow back as well, where the ideas that are happening out there are flowing back into our own research. So we're seeing it all the way. The point is that the tool itself acts as a medium for conveying these ideas around. I have to give credit. I'm going to just show you a little bit of Trillium here. I have to give credit where it's due. Trillium stands on top of a bunch of wonderful packages. The D machines, of course, and Interlisp runs on all of them, and that's been very important. The fast construction, and then the ability to actually deliver them to the community. It's been absolutely crucial to have Trillium running on software. On hardware, which is in place in Rochester. Early on, it was difficult. I had to spend quite a bit of time in helping them actually get a hardware base. As the dandelions become more available within Xerox as a whole, we're finding that medium for carrying Trillium is being supported in a way which allows them to actually pick it up. InterLisp D has been invaluable for doing the fast prototyping that I do, but there is also what the community is going to do. I will mention what they are doing, and InterLisp D is crucial there, or at least an environment in which you can do modification of Trillium itself. I use all sorts of packages within InterLisp, and so I'm standing on top of that. So that Trillium is a small piece of glue tying together a great pile of stuff. Well, let me do a quick demo of what Trillium is and how you design with it, and then we'll go back to the description of what it's been like in each one of the different sites where it's in use, or at least 4 of them. You've seen this business of pushing buttons. This is the 5700 display or something like it. As I said, it's got to behave, not just look. As you've seen from this particular interface, and as is true on the 5700, an interface is a collection of frames which you move among. Each frame has a collection of items. Here's a number pad. In fact, let me go back and point something out. Here you notice that things sort of stopped after a while, and there was a sort of the standard interaction, but then you get some funny ones. It has to do with constraints underneath the interface, namely no more than 99 copies. You can't make one-sided copies from two-sided originals. Those are problems for the designer to how is he going to convey those to his operator. There are lots of different ways of doing it, having to do with coercion, having to do with refusing out of hand, or having to do with actually collapsing the dimensions. So you can express the constraints in lots of ways. You can also, people want to tinker around with different sizes, whether you use direct buttons or cascade, whether you use graphics in funny ways. These are all the kinds of things that designers want to do. Back to this, what I've got is a collection of items within each frame. There's a number pad. This one is a button which changes frames. Here's something which, a set of buttons which puts a value into an underlying cell, which then gets reflected in a number of different ways. Each item has a type, and by virtue of that, a collection of characteristics. And now, for the first time, I'm going to start actually putting on my designer's hat. What I want to do is, in fact, let's say, move this guy around. Let me, in fact, take a look at the characteristics at this guy. What I get is an editor for him. What I can then do is tinker with them. Let's, in fact, I don't know, let's change the border, the border width, for instance. What I get is the right kind of editor for that sort of value. Let's make it 5. What we get is a slightly wider border. You can play with the font. You can play with whatever the designer of the abstraction lets you play with. These abstractions, however, particularly number pads and things like that, are in fact composed of smaller pieces. What I've done is shown you the cascade of things, which is I'm just hinting at the way you describe new abstractions from old ones. Here's a collection of buttons which all affect the same cell, this one or that one. They, in fact, in turn, each button is described as, well, you get a collection of buttons, each button sort of lined up and affecting the same cell. Each button has some graphics, a underlying sensor which senses when you touch, and a displayer which reflects the values back. So you get this cascade of various different, which make up the composites. At the bottom you get these primitives in terms of which all the behavior is described. And that's built into these primitive things. If I take the primitives and group them another way, what I get is the following. I get a collection of sensors. Well, first, I get some artwork. which is just the static stuff. I get some sensors, which are looking at the world. They, in fact, cause changes in an underlying machine, which behaves, and then a set of displayers which reflect it. A separation of the display, the presentation, from the underlying model. Now, the model here, and this is the only part of Trillium that, in fact, captures a theory of design, is that it says that it's important for the designer in thinking about his design to understand, to articulate what it is that he expects his operator to have to understand. Then he can, in fact, decide whether or not his presentation is doing a good job of that. The underlying model is described in Trillium in quite a simple way, and it supports only fairly simple machines. Some initialization is you enter a frame, a collection of cells, which are the sort of define a state vector, each of which has values. Some implications which propagate values between cells, and some inhibitors which prevent cells from taking on particular values. What we get then, that's a very quick technical look at what's under Trillium, is a 4-level pattern of design. You get a set of researchers. In fact, now, the story is what we're getting is a community of people building Trillium itself. I should cross researchers out and say it's the community which is constructing in Interlist D the design environment. We have support programmers who are modifying the underlying primitives or creating new ones. That's where all the behavior is described. You have advanced designers building new composites. And the fact that they can build new composites allows the language of design to grow. As long as you have a computer-aided design environment, which is what this is, which has a fixed set of pieces, you have a fixed lock on the conceptual set of the designers. Those are the pieces, that's the way to describe it. If you can create new ones, then you allow the design vocabulary to migrate. And by virtue of the fact that Trillium is shared, in fact can migrate around the community. And finally, you have the designers who are actually putting interfaces together out of the items that are there. Key to making technically, the key to making a lot of this work, particularly the composites, is the idea of making all of the knowledge of the abstractions explicit to the program. So what we have is a construction set, kind of direct behavior, direct manipulation of pieces. Primitive abstractions which describe behavior, composite abstractions which describe subassemblies. We have the explicit representations of lots of things and the separation of the presentation from the model, the logic of interaction. Well, now what I want to do is shift gears a little bit back again to the question of what was it like. How did it? What happened when we tried when people who are designers started wanting to get Trillium? And it has been in all of these cases a pull from their side rather than any push from this side. This is the timeline. I'm going to talk about it. I've already talked about IDEO. They were in from the beginning. Adirondack, which was originally called Pathfinder, is a big copier. They were in about a year later, and all these folks are continue to use Trillium. Spitfire is, Adirondack is actually in Rochester. IDEO is in Rochester. Spitfire is in El Segundo in PSD. That was about a year after that. And then just this past winter, Venture, which is a follow-on to the 1075, has picked up, has decided that they will use Trillium. I'm going to take these in the following order. I'm going to talk a little bit about IDEO, then about Spitfire, because it's a fairly simple case. Adirondack, more complicated, and Venture, a very interesting portrayal of what can happen when you put something fairly simple into an environment which in ways that you wouldn't quite expect. Let me look at these people slightly differently, just so that those of you who don't have a clear map of what's out there will pick it up. You know, Xerox this is a Trillium view of Xerox. We have the CEO, and then in addition to other things, the business equipment groups, which cover two major, well, for our purposes, two major groups, the RBG, the Reprographic Business Group, and the Xerox Systems Group. Within this, there is all the copier, the copier development, high volume, mid volume, low volume. Venture is a high volume machine. There's also the Strategic Business Office within RBG, which includes IDO. And so this is the starting place for our connection. I show the operability project as a connection between these folks who are supporting all of the copier design work and ourselves in Corporate Research Park and ISL. The Xerox Systems Group has, again, a number of different groups, but includes centralized printing and something called printing systems. Adirondack is a digital copier that's in centralized, and Spitfire is a small printer, and it is in PSD. There are various other people using Trillium, which I'll mention in a while, but these are the major ones. Well, okay, let's talk about IDO. A lot of the work was spent in actually getting machines, helping them bring them up. Then they had to learn how. They had to train others how to use it. They got into the training business. But what they have in fact used Trillium for are two things: the comparative work of various different features that they could put on a machine and how to represent them, and then in support of lots of different programs. What I want to do is show you briefly, in fact, some of the things that they have constructed. Now, I'm showing you here, everything I'm showing you, it came from the groups that constructed it. I haven't made up any of these slides other than to just make copies of documents that they have constructed as part of their normal work using Trillium. Descriptions of BitBlit, which is something you tend to have to get to know, and what it actually means to designers. Documentation for Trillium itself. Description of all the various different pieces. Descriptions of the abstractions which they find themselves using. Various different kinds of buttons. And then these comparative studies in which you see all sorts of different ways of doing reduction and enlargement, for instance. So that's the kind of thing that they have used Trillium to put together. I have copies of various different documents that these are taken out of, sitting at the front if any of you are interested. You've had a chance to see this. A lot of the work was getting the machines, getting the networks, and it's getting them purchased, delivered, installed, and serviced. Their service comes out of Washington, D.C. We had designers who were putting chips into memory boards because until it got to the point where the service was close enough. There was a lot of just plain hand-holding in getting them up to speed that way. This was within IDO. Learning how, they had to pick up all these various different pieces. It's a culture which doesn't have this sort of technology, so that we had to bring them up to speed. A crucial thing which came out, which I lucked out on the first time and have now focused on, was having local programming support. I lucked out because Kathy Matisek was already in the IDO environment, in the Sanda operation. And what's been important is that line of people who understand the underlying technology has been a buffer for me, because questions go there first and for the most part get answered, and then they come to me. And that made it possible for not only for me to get some more work done, but more crucially, for them to begin to think of themselves as people who own the technology. They got involved and they began to own it. So local programming support has been really crucial in all of these situations, each of these sites. it was one of the things that made Trillium catch on was the fact, within IDEO, was the fact that it had an immediate appeal to people at the place where they were. In the end, what happened is they shifted their head around and thought about their interfaces in different ways. But to start with, what happened was they saw it as a graphics design tool. And a crucial point in fact, making these things go, I think, is having them be something that you can get your hands on, you can see the need for right away. Then, once you begin to understand it, you can, in fact, change the way it goes. I think often what we try to do is say, here's a great way, here's a great new thing. If only you'd put your head on totally differently, then you'll see what I mean. It's just hard to make the transition that way. So we lucked out, again, because it was a tool which helped you do graphic stuff. Management was, in fact, very, very helpful in making this environment work. Now, that was a pretty routine sort of put it in, support them. Now let's take something that's a little bit different. This is Spitfire. What they were doing, as I said, it's not the next one in time, but it's interesting. What they were interested in doing was doing fast prototyping on a small printer. The crucial thing, the interesting thing about this one was that the delivery hardware was not high-end. They were going with a small machine with a character display, keyboard kind of selection. What they did is they mocked up their environment. Of course, they put a snazzy front end on the Trillium description. What they then did is use Trillium to build some abstractions for putting up menus, and in fact go ahead and play with what the menu structure should look like. It allowed them to start quickly exploring the space of all the various different menus and how it would go and how it would get explained and walking around inside that space. What very quickly happened once they got this up was that they found that the programmers who were going to have to do the construction of this of the final product were hanging around trying to see what it would look like. And what they then began to get is this bunch of people, in fact, talking. What they produced was a complete description of the interface, which the software designers then used are coding against. The thing that makes this sort of routine use of Trillium another aspect of the routine thing is that when they got Trillium, it did not do displays. It did not do sort of that keyboard kind of stuff. It did not have menus, and it didn't listen. It didn't listen to the keyboard. What it had to do is standard extensions at the primitive level, and then they ran. So that this business of getting Trillium into a new environment, and then suddenly what you do is you modify it a little bit, and then it runs, is sort of a fairly standard thing. IDEO did not do it, but at Spitfire, they in fact make the modifications and run. Again, there's already the beginning of that involvement. All right, let's take a look at Adirondack. This is a larger copier center machine, duplicator. It's a digital machine. They already had in place an organization which had designers separated from software folk. They had D0s in place. What they did was put together a much more complicated interface, and they did something very interesting to Trillium itself. Well, let me show you what they actually built first. Quickly, they were doing a fairly standard kind of push button interface for operations. However, they also were interested in helping the service folk. Now, the people who were doing the service work on Adirondack were the people from RTSDD originally who said that they didn't think that Trillium was going to help them and pointed me at IDEO. What's happened is it's come full circle. They've seen how, in fact, there's an interface there, something to do. I don't expect you to understand these. I just want you to see the kinds of things, the marriage of stuff that's already there, the standard FuncDoc, which the service folks use to fix the machines. And the kind of active part down here at the bottom, which is walking them through the fault isolation procedures, telling them what the probable causes of the thing are, of the error that they're looking for is. The interesting thing that they did, let's see. So they've extended Trillium again. Because they had a sophisticated set of software folks, had provided a home away from home for Trillium. It became a place where there was known software expertise. During last summer, I let the sources for Trillium go to them for the summer, and then they handed them back to me at the end of the summer. This summer, they did the integration. They took the sources, pulled in all the changes that had been made in the community, and did the release themselves. They now own it. So what's happened is that this home away from home, this identification of a place where Trillium could live other than here, happened naturally because there was an environment where there was a sophisticated set of programming support. The other thing that I was leading a little earlier to was this notion of automatic translation. What they did is they said, gee, we've got this interface described in Trillium based in interLispD, but that's not what we're going to have on the final product. Wouldn't it be nice if we don't have to go through another software thing of programming it up? So what they wrote is a simulation, or they reproduced the Trillium underlying machine, and they wrote a translator which takes the description in Lisp or Trillium and writes the appropriate thing. Now they were going to a fairly nearby neighbor. They were going from interLisp to a Mesa world, and the Mesa world had BitBlit. It had the mouse. It had Windows. So all of these things that Trillium was counting on, they already had. It was a fairly simple translation into a world that was nearby. I make that point because when we get to Venture, you'll see that that particular thing was crucial. All right. One of the nice things about this translation was the fact that it provided a crisp description interface between the people who are doing the software, the underlying software support of the thing, and the designers. Secondly, it allowed the software folks to say, we can't do that in our world. We reflect it back in the abstractions into the Trillium world, which provides the designers the feel for the ultimate hardware. The point is that it's coming back out of the software world into Trillium through the underlying abstractions, that they can see the realities reflected back up into Trillium. And it completes the design process in the sense that you're trying to get it onto the end product. A year ago, when a vice president was coming through for a review of the project, they, half an hour before the presentation, they were in there in Mesa tinkering to get the last thing to behave. They translated it and they were tinkering in Mesa. 6 months ago, a half hour before the next review, they were tinkering in Trillium and then doing the translation down. The point is that what you've got now is fast turnaround right down to the end product. The reason you want to get to the end product is so that you, in fact, are driving the real machine. They were making copiers using their interface, making copies using their interface. All right, Venture. Last summer, a follow-on to the 1075. They wanted to do they weren't sure whether they were going to go. They knew on a display. They weren't sure whether they were going with color or black and white. East Rochester had an environment in which they could build color. What they asked IDEO to do was, in fact, build something in black and white. And IDEO took the opportunity of exploring the design space. Some quotes from a letter written by Pat Wall in support of Venture includes the following comment. Trillium held up extremely well in design sessions where 4 or 5 designers would sit around the screen and brainstorm graphic representation strategies. Being able to illustrate concepts on the spot facilitated the design process. The original venture interface capability estimates have been revised to include several effects illustrated in the demo interface. The point about it was, again, that there was this involvement with people and actually exploring the design space. They had this, in the end what they did was they had a bake-off between the two systems. Just before I tell you what the answer was, what I want to do is show you a little bit of the black and white interface that they put together. Can we roll that, the videotape?
We have a choice of languages to operate this equipment, and we select English. Here is the full screen showing the picture available on the display. Paper is available from one of several areas. Uncollated or collated copies can be selected, and the illustration changes accordingly. Next, we make a change because we have one-sided originals and want two-sided copies. And the picture changes when we select covers. Now we are signaled to pick the covers from location 2 or 3. On the finishing panel, we can have one staple or two staples in our copies. We select 2, and we also choose tabs. Now the image on side 1 is shifted to the right, and the picture tells us just how far. And we also shift the image on side 2 to the left. Moving on to the next panel, adjustments are automatically made because we have photographs in the originals. And now we want to see a proof copy, so we press this button and then the Start button. As the copy is being made, there is an illustration on the machine picture. Our proof copy indicates we should make one change in photo contrast. Then we can proceed to the reduction enlargement panel. We need to reduce in order to get the original to fit on a copy. And now we reduce even further, seeing the picture change on the right as we go down to 68%. Several other panels will be available later but are still in preparation. Returning to the copy mode, it's time to select 13 copies and press the Start button. On the illustration, we can see the copies being made. There's a flashing signal after the 4th copy, however, and the picture tells us that there's a jam in the document handler to touch the document handler in the machine picture for instructions. And the animated display will tell us and show us what to do. Open the left cover, remove the document, place it face up on top of the document stack. Close the left cover, open the right cover, remove the document, close the right cover, feed it face down into the document slot. Press Start, the job will be completed automatically. And in the illustration, we see the copies being made as we complete our 13 as requested.
Now, what happened here was that this was a real copier program. There were competing organizations, the designers, the programmers, the managers, the planners. There's a lot riding on the success of this program. There are a lot of politics involved with it. What happened was IDEO took the opportunity of this comparison to do some early exploring, and again, as with Spitfire, the involvement of people produced an emotional commitment to the design. As a result, what happened is a new basis for the evaluation of design became acceptable. In lots of the other disciplines, engineering, for instance, whether or not the thing works is just as important as how much it costs. In design, it was always the case that designers had to explain how much the thing cost. And of course, they didn't know how to answer that question, and so they really didn't have a basis in which to argue. What happened was sort of the quality of the graphics, namely the art of the thing, became something which people were felt was important, and the things which were going to support operability, for instance, the animation, became something which was the program was willing to sign up for. And when the programmers, the software support folks said, but we can't do that, the program said, well, maybe you better go back and think about how you can. What happened is it changed the power patterns. It changed the roles of various different people. So here's something which you wouldn't necessarily expect right away, is causing a complete shift in the way in the balance of the various different roles within that program. Again, they extended the functionality of Trillium. They did an automatic translation too, but now they were going to. Their anticipation is to go to 8085 hardware, without Adirondack having done it in a case where it was close. They never would have tried to do this, because we've heard arguments about that 2 years before, saying, we don't want to use Trillium for doing our design because we're not going to have a Dolphin in our copiers. The point is that by the intermediate step to a near world made the possibility of the distinction between the design environment and the running environment clear. Point again being that the community of users of this single tool is allowing cross-feed between the various different groups. Well, what happened? Various different competitions became collaborations. Instead of the programmers and the designers fighting, what they did is they both stepped back into their own areas and said, you design, we'll figure out how to make it run fast. And with respect to the bottom line, they decided to go with color using Trillium. Of course, Trillium didn't do color. And so what has happened was that has forced a collaboration between East Rochester with a color environment, a good hardware color environment, and the support environment for Trillium. So that it can do that. This is an interesting case in which a part of the company forced a collaboration, if you like, or rather enabled a collaboration between two parts of research, because East Rochester is research. They're saying we want it, and we're willing to put bucks on the line, enabled some of the collaboration. All right, so there are the four different groups. What happened? Okay, other users, you've seen documentation of Trillium training material. The AISBU, the people selling the 1100 series machines have been using Trillium as a demo. Leesburg is using it to explore in some simple explorations of some service ideas. We've used it around here for making control panels for Lisp applications. And Rank Xerox is going to be getting it for doing their operator interfaces during the fall. Well, how is it that the separate sites became a community? First, I just interacted with them independently. Then they began to talk to each other. Materials began to get passed around. Communications were crucial in this. The lore about Trillium, the interfaces, the abstractions, the idioms, how you use them, documentation and training. I didn't do any documentation or training. That was left to IDEO. That was their problem, and so they began to talk to each other, to the other folks. When someone says, I want it, you turn to them. Then, this was crucial, code began to get passed around. People made modifications and put it into the community. Put it out where people could get it. They made additions. And then as I mentioned, we started passing around the definitive set of the sources. Regular meetings were held. Everyone was encouraged to contribute, and we let everybody take credit for what was happening. Again, there's the sense of commitment. There's an Innovators Week in Rochester, and for the last 2 years, there have been people from various different programs who are using Trillium, showing Trillium. They're part of the community, and they're proud of Trillium. Everybody takes credit for that. All right. How did the community actually get recognized? Well, there was concern for the fact that the support was here in research, and that's inappropriate for important product programs to be standing on top of people here in research. So having them on the critical path. So what happened was, and the second key thing was that the IDO support was needed on the venture program, and it made it very clear that everybody was standing on shaky ground because there was a limited amount of support. So there was the recognition by people within RBG, Barry Bebb in charge of advanced product technology, to support they recognized the community of people who were talking and picked out and gave people the charge to actually take over and manage Trillium within that group of cooperating people. And they approved full-time site-independent support programmer who will be here for a while and then may move into their community. This summer, there was the first integrated release from outside Park, as I said, and that allows me to go back to being a regular member of the community and continue to do the research on Trillium. In particular, I'm very interested in how it is that you support a community like this. What we've been doing is using the file servers and the mail system for pushing things around, but we need more structured support of a database and styles of usage which will allow people to understand where the pieces are and find it, record the record of design, be able to, in fact, have the rationale for the designs, all of these things that have to do with supporting design. Well, just to wrap it up, that's the story. What about technology transfer? From this, I take the following lessons. First, it's a process of bridge building, if you like. It's not, in this particular case, it's finding people who will come and construct together a cooperation. The goals don't necessarily need to be the same for everybody, and in fact, various different groups may not understand what's driving the other group. It's not important, provided you can find activities which everybody can bring their own unique skills to. How is it that a community like this acquires something like Trillium? First, that immediate felt need, the low inertia to get into the system itself, with deep insight coming with time. And then ownership being established through personal investment, investing time by extending the system in the various different ways, by actually improving it, redesigning things that I did badly, that other people did badly. And then establishing for everybody a sense of contribution. It's a sense of getting, there's where the sense of ownership comes from. What does it require? It requires people. The organizational level has to foster it, has to in fact reward it. Management needs to understand the way that is going on, and again foster it. And one of the things about organization is this often cuts across organizations, and so there has to be the willingness to not live within existing organizational boundaries. This is a guerrilla movement basically for a while until it gets recognized. And then the staff who are actually doing it have to in fact get to know each other, establish bandwidth, be willing to work on the bridge rather than on their own home turf. You need the support, the machines, the networks, the software system, the documentation, and the training. And you need the communication and the support for that. I spent a lot of time on a telephone. I was going to bring up my stack of mail for the project. It's about that high over the past 3.5 years, just on the operability project alone. Spend time traveling, meeting with them. You need the file servers and the databases. And you need time. It's taken 3.5 years. Questions? Rick?
But another requirement, if we went back to that slide, it's missing. Another requirement is the problem domain. That you have to contribute something that's not in competition with the people that you're supplying it to in research. You were building a tool, the tool was required, they didn't have the resources, or that they were interested in acquiring a tool, so therefore this bridge had this immediate appeal. Phrase comes from the previous slide.
That's certainly true.
That's a narrow place in which research can provide tools to the product community.
Well, there's a whole group within RBG and groups within all of these design environments, which in fact are responsible for nothing else than tools. So it was in strict and direct competition. However, your point's still valid, because in going into the design community, IDO, I was not in direct competition with anybody in their organization. Another point about the organization is that in that particular case, it provided a nice firewall so that we could do something within there without, in fact, necessarily having to get the approval of the people who might have found it walking on their territory. Okay, thank you very much.